Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 28, 2025, just 3 days ago. This paper proposes a new way to train vehicle detectors for aerial images that boosts performance by more than 50% over some existing methods. The paper is titled, Adapting Vehicle Detectors for Aerial Imagery to Unseen Domains with Weak Supervision, and it tackles a really common problem in machine learning called domain shift. Essentially, the authors use generative AI to create new, labeled aerial images, helping the model adapt to different geographic locations. Also, the authors shared their official code on GitHub. When you check it out, you'll see it's still a bit of a work in progress. The core usage sections are under construction, but you will find the initial setup instructions, dependencies, and pointers for data preparation to get started. Alright, so this first figure gives a great overview of their whole pipeline. The process starts with two datasets. One from a source location with detailed labels, and another from the target with only weak ones. They use both to fine-tune a stable diffusion model, which generates new synthetic images. Crucially, it also produces cross-attention maps, which highlight where objects like cars are, helping to automatically create labels. The bar chart at the bottom shows their new detector's performance, handily beating both a standard detector and an open-set detector, which is a model designed for unseen environments. Building on that idea, this diagram really shows the nuts and bolts of the process. Okay, so on the left, you see the input, real aerial images from a source, say New Zealand, and a target, like Utah. These are fed into a denoising U-net, which is the core engine of the diffusion model. It learns to create new images by removing noise, guided by specific text prompts. The real magic, though, happens with the cross-attention maps. These maps show where the model focuses to generate the cars from the prompt, effectively highlighting them for automatic labeling. Moving to the results, this table really puts their method to the test. It compares different approaches for adapting a detector from one location, like the LINS dataset, to another, the UGRC dataset. The key metric here is AP50, which basically measures how accurately the model finds cars. A higher score is better. As you can see, their method, listed at the bottom as ours, consistently gets the highest scores. For example, using a YOLO Vi8 detector, it hits 75.4%, a huge jump over other methods, which really validates their whole generative approach. This next table then digs into why their approach is so effective. It's an ablation study, which means it tests a specific part of the system. Here, they compare using a single cross-attention map, the base method, against using their multi-channel stack method. This stacked approach combines the map for the word car with maps from two special, learnable tokens. These are like custom words the model creates to better understand the car concept and the background. The results are stark. Stacking the maps improves accuracy significantly, boosting the score by over 5% in some cases. And this figure gives us a fantastic visual for why that stacked approach is so effective. On the far left, you see the synthetic images the model created. Now, look at the second column. Those are labels generated using only the cross-attention map for the word car. Notice how it sometimes misses vehicles. But in the third column, using their multi-channel method, the labels are much more accurate and comprehensive. The heat maps on the right show the secret sauce. Each one focuses slightly differently, helping to cross-verify the location of each car. So to wrap things up, this work shows how generative AI can help object detectors adapt to new environments. Their key innovation, using multi-channel cross-attention maps, creates high-quality, automatically labeled data that dramatically improves performance. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.